Maupay adlaw sa iyo nga tanan. Welcome to Engineering e-learning channel. Our topic for today for simplified integral calculus under Unit 2, integration technique, integration by partial fraction, part 2. We'll be dealing case number 3 and case number 4. So for case number 3, fraction with repeated factors in the denominator. For each quadratic factor, quantity ax squared plus bx plus c in the denominator, where will be the quantity b squared minus 4ac is less than 0, there corresponds the sum of two partial fractions in the form of a quantity 2ax plus b all over quantity ax squared plus bx plus c, where your a and b are unknown constant. But wait, if you're going to check and evaluate our function, 2ax plus b is only the first derivative of your denominator. Okay, if we take the first derivative of our denominator, ax squared plus bx plus c, that is your x. This is equal to 2ax plus b. I hope it's clear. So let's proceed to our first example for case number 3. Okay. For your first example for case number 3, please take note that the first partial fraction is so designed that a times the derivative of the denominator so that the logarithmic function formula can be directly applied in evaluating its integral. The integral of the second fraction will be evaluated using inverse trigonometric function formula by expressing the denominator as a sum of two squares. So, okay, let's evaluate our given example. So example number 33 can be found in your workbook on page 114. So evaluate the integral of 4x plus 5 all over x squared plus 4x plus 20. So we need to resolve the integrand into sum of partial fraction. If we recall, for case number 3, the factor in our denominator is a x squared plus bx plus c, and it's equal to its term in partial fraction decomposition to a x plus b all over a x squared plus bx plus c. We all know that our x at the numerator is only the first derivative of our denominator ax squared plus bx plus c. Okay, so let's rewrite our function in terms of partial fraction decomposition. Okay, so 4x plus 5 all over x squared plus 4x plus 20. Okay, so this is equal to a, the first derivative of your denominator, that would be 2x plus 4 plus b all over x squared plus 4x plus 20. But this is also can be written into, if you're going to distribute your denominator, this is also equal to a 2x plus 4 all over x squared plus 4x plus 20, plus you're going to distribute your denominator, this is b all over x squared plus 4x plus 20. Of course, we need to equate our equation, multiplying both sides by x squared plus 4x plus 20 all over 1. So if we equate, so this is only equal to, so multiplying both sides, so your equation will be 4x plus 5 is equal to a 2x plus 4 quantity plus b. Now that we have our equation, we need to further simplify. This is also equal to 4x plus b is equal to, we distribute the a to our quantity 2x plus 4. So it will become 2ax plus 4a plus b. If we're going to equate the coefficient of x, okay, so equate coefficient of x with respect to a, so we get so we need to equate coefficient of x with respect to a. If we're going to equate this equation with respect to a, x, so we only copy the function with x. I mean the term with x. So we have 4x equal to 2ax, 4a plus 4b. Okay, so we can say, if we cancel x both sides, we can have 4 is equal to 2a. So we can say that Ra is equal to 4 over 2, or a is equal to 2. So we have an answer for our letter A. We have 2. So let's continue to evaluate and get the values. If we equate this equation to our constant side, equate the constant, we have a constant 5 at the other side and 4a plus b at the other side. Since we have a value for our a, we can substitute it right away. So 4 times 2 plus b. So finally, our b is equal to, we have 8. We transfer it to the other side. That will be negative 3. So 5 times 8, that's negative 3. So that's our value for our b. We already have value for our a. So what is our next move? So we substitute the value of our a and b to our partial fraction decomposition. Can use this partial fraction decomposition. See, if we rewrite, that's the integral of 4x plus 5 all over x squared plus 4x plus 20. Okay, so we can rewrite, that's a, we have 2, quantity 2x plus 4 all over x squared plus 4x plus 20 plus rb. What is rb? That's negative 3. over x squared plus 4x plus 20. So now we can apply our trigonometric formulas. So we have, this is our first term, our dx also. Okay, so let's move to next page. So we can integrate the given term in partial fraction decomposition. So this is integral 4x plus 5 x squared plus 4x plus 20. This is 2x plus 4 x squared plus 4x plus 20 plus our negative 3 all over x squared plus 4x plus 20 integral bracket and our dx. We can apply our property number 1. We can apply our property number 1 here. Property number 1 and 2. We distribute the integrand inside each term and the dx and carry out real number constant outside the integrand. So it's 2 integral of 2x plus 4 all over x squared plus 4x plus 20. So here, negative times positive, that's become negative. Then you carry out real number constant 3. The integral of dx all over x squared plus 4x plus 20. In our first term, we can use our logarithmic formula right away. Take note that 2x is only the first derivative of your x squared plus 4x plus 20. So you don't need to integrate that one. It will go back to its original form if you're going to integrate. So we use our logarithmic formula right away here. So if we recall our logarithmic formula number 3 is equal to du over u is equal to ln u plus c. So again, we don't integrate 2x plus 4 anymore since it's the first derivative of your denominator. We can say that this is also dx. Okay, it's complete equation. So using our logarithmic formula, 2 logarithmic of x squared plus 4x plus 20. So we are okay with our first term. So moving on to your second term, negative 3 integral of dx over x squared plus 4x plus 20. Okay, so we need to factor out x squared plus 4x. Okay, so x squared plus 4x plus 20. So if we factor out, we can rewrite x squared plus 4x plus 4 plus 16. Okay, so we have, if we factor out x squared plus 4x plus 4, we can have x squared x plus 2 squared and the square root of your 16, that is 4 squared. So we already have our u and our a. So we can use our logarithmic, our inverse trigonometric formula, number 17. What's ITF 17? So that is integral of du over a squared plus u squared is equal to 1 over a arctan u over a plus c. So we can use this to our second term. So rewriting the second term, that's equal to negative 3 integral dx all over our factored out terms. So we can say that this is 4 squared plus x plus 2 squared. So you have your u and your a. So you can use it right away. So negative 3 arc. So that's negative 3 quantity 1 over a, that is your 4, 1 over 4 arctan, what is your u, that is your x plus 2 all over a, that is your 4 plus c. Then you multiply your constant negative 3. Finally, you have your 3 over 4 arctan x plus 2 over 4 plus c. And copy your first term value or your answer in your first term, that is 2 ln x squared plus 4x plus 20. And finally, this is your final answer for your example number 33. Okay, moving on to your next example. Okay, for your next example, for case number 3, example number 34. Evaluate the integral of dx all over x to the 4th plus 6x squared. Okay, your example number 34 can be found in your workbook on page 115. Okay, so let's start. Let's rewrite first our function to our partial fraction format. So that is equal to dx x to the 4th plus 16x squared. So we can furtherly rewrite. So we need to factor out what's common in the denominator. So we have a common of, so we can write this as 1. So we have a common of x squared, quantity x squared times 16. If you multiply x squared inside, it will be x to the 4th and 16 squared. So we carry out our x squared for the meantime. So we have dx. So we write our partial fraction decomposition. So we have our repeating linear factor x squared. So same with our case 1 and 2, we write it as a over x plus b over x squared plus, since we have only one distinct quadratic factor, we can write it but with a power of 2 since it's a quadratic. So distinct quadratic factor, we write it as c x plus d all over the distinct quadratic factor, which is x squared plus 16 dx. Okay, so we need our equation. So we need to multiply our equation both sides. So we multiply with x squared over 1 and x squared plus 16 over 1. So we multiply these both side of the equation. Okay? So we cancel the other side here, this one, and x 16 plus this one. And the other side, we cancel here and this one. Go rewriting our equation. So we have 1 ax, then the remaining so we copy only these two. Okay, for our b, we have b, if you multiply with x squared, the remaining is x plus 16. For our cx plus d, if you multiply this one, we have only our x squared. Okay, we have now our equation. So what is our first thing to do? We try to assume values. If we let x equal to 0, okay, if we let x equal to 0, we have 1. Here, almost everything will be 0. If we substitute 0 at x, everything will be 0. At b, same also. At b quantity 0 squared plus 16. So it's not become 0 since it's a positive 1. So here, same, it will become 0. Finally, we can say that our remaining one is b 16b. So we can say that our b is equal to 1 over 16. We have a value for our v. Our next step is to assume another value. If we let x equal to 4i, what do you mean by I? That's imaginary number, which is equal to negative 1. So 4i times negative 1, that is negative 4. So I use I to efficiently eliminate constant when I substitute the value for I for this equation. So this one equal to a 4i, then 4i squared plus 16 plus b. We already have a value for our b, 1 over 16. Okay, so take note, 4i squared plus 16 plus our c. What's our x? That is 4i. What is our d? We don't have yet a value for d. Then multiply x 4i squared. Okay, so the remaining a 4i. If I apply the value of 4i, that is I is negative 1 times 4, that is negative 4 squared, that is negative 16. So that is negative 16 plus 16, it will become only 0. B, we substitute the value of our b. But here, same, if I 4i squared, that is negative 16, that it will become 0 also. C will become 4ci plus d times it's negative 16, since 4 negative 1 times 4 squared, that's negative 16. Okay, so let's eradicate. So this will become 0. A 4i times 0, so it will become all 0. B, if you substitute, it will become also 0. The remaining is 4ci plus d times negative 16. Okay, so rewrite it here. So we have value of our 1 both side, 1, and the remaining we have, so this will become 0, 0. So negative 16 times 4, so that is negative 64 ci. Okay, we have a value, and 16 we have still d minus negative 16d. So we have an equation under our x is equal to 4i. If we equate our equation with respect to c, we have 1 negative 64c. If in terms of c, okay, this is 0. So we can say that our c is equal to 0. Since 0 over negative 64 is still 0. If we equate our equation with, in terms of constant, we have negative 16d and 1. We have 1 negative 16d. So we can say that rd is equal to only negative 1 over 16. Do we have a complete value? So b, we have our b, we have our c, 0, and d. We only still have a to determine. So for our a, we can assume x equal to 1. So moving on to our next page. If we let x equal to 1, so I'll write our equation, that is 1 equal to ax, x squared plus 16 plus b, x squared plus 16 plus cx plus d, x squared. So we substitute x with 1. So 1 plus 16 plus b1 squared plus 16 plus c1 plus d1 squared. Okay, so the remaining, we have a value for our a, we have a value for our c, so we have value for our d. We substitute it right away. So we can have 1, so this is 17, so this is 17a, plus here We also have b 17b here. So times 1, 1, we have c plus d. But we have a value for our a, c, and d. Substitute it, we can have our 1, 17a plus 17 times 1 over 16 plus what is our value for our c? That is 0. For d, that is 1 over 16. So finally, this is 1 17a plus 17 over 16 plus 1 over 16. D, I think your D is negative 16. Okay, so correction, this is negative 16. So your sign here become negative 16. Okay, so finally, we can say that our A is if we 17 over 16 minus 1 over 16, that is equal to 1. Okay, if we, so it means we multiply or we cancel out 1 both sides. So the remaining is 0 is equal to 17a. So finally, RA is equal to 0. Since 0 over 17 is still 0. So we are complete. We have a value for A, B, C, and D. Okay, so we rewrite our function. So integral 1 over x squared quantity x squared plus 16. Integral. So what is the value for our A? That is 0 over x plus b x squared. So we replace already with the value since we already know. So what is the value for our b? That is 1 over 16 plus c. What is our c? 0 x plus what is our d? Negative 1 over 16 x squared plus 16 dx. So that's why I didn't use the first derivative of x squared plus 16 since our c is all 0. So whatever value we multiply with this value, it's the same. So let's remove the 0. We have 1 and 2. So we have a remaining 2 function. X squared. So we have a negative. So negative times positive become negative 1 over 16 all over x squared plus 16. Excuse me. Dx. Okay. So we apply property number 1 and 2. Property 1 and 2. So we apply the integrand inside the function, inside the quantity, and carry out real number constant so we can finally use our integral formula, logarithmic formula, and ITF, integration inverse trigonometric function, number 17. Okay, so moving on to your next page. So 1 of 16 x squared minus 1 of 16 x squared plus 16. So we distribute, we apply property number 1 and 2. So we carry out real number constant. So this will become 1 over 16 integral of dx x squared minus 1 over 16 integral of dx over x squared plus 16. Okay, so in our first term, we can use logarithmic formula right away. So we can write it to 1 over 16 ln of x squared. How about for our second term, 1 over 16? So we arrange it to ITF format. So that is integral of dx. So the square root of 16, that is 4 squared plus x squared. So we have x squared, so we have our a and we have our u. So we can use our inverse trigonometric formula number 17. So if we rewrite, that is 1 over 16 times 1 over a, our 4, our tan u, what is our u? X squared over a, that is our 4, and our constant, arbitrary constant c. So we multiply 1 over 16 times 1/4, that is 1 over 64, arctan x squared over 4 plus c. Then we copy our first term, that is 1 over 16 ln x squared. So finally, this is our final answer for our second example. Sample number 34. So for question, comment down below, or you can send your question to our GC, or you can personally message me to our model. Okay, moving on to our next example. So for our case number 4 example. Okay, correction for our second example for case number 3. What is my correction? Our first term, since it's power, we can use our power formula here. So negative, that is 1 over 16. If we use our power formula and make this negative, so it will become x negative 2 plus 1 all over negative 2 plus 1. So it will become correction, okay, correction. So that is 1 over 16 quantity, use our power formula to become x negative 2 plus 1 all over negative 2 plus 1. So it will become 1 over 16, that is negative 1. So this will become negative, and the remaining is negative 1. So we can rewrite our final answer. So it's negative 1 over 16 x raised to negative 1 minus 1 over 64 arctan x squared over 4 plus c. So that was only a correction for your final answer, since we wrongly use wrong formula here. So we use logarithmic formula, but logarithmic formula is not applicable since our denominator is in power form. So we use power formula. So this is the corrected final answer for your second example, case number 3. Okay, moving on to your case number 4. Okay, let's discuss case number 4. Case number 4, fraction with denominator involving a repeated quadratic factor. Okay, for each quadratic factor, function ax squared plus bx plus c raised to k in the denominator with quantity b squared minus 4ac is less than 0, there will be 2k number in partial fraction in the form a quantity 2ax plus b all over ax squared plus bx plus c plus your c 2ax plus b plus d all over ax squared plus bx plus c squared plus a sub k quantity 2ax plus b plus f sub k all over a x squared plus bx plus c raised to k, where a and b are unknowns constant. Take note that ax, which is your 2ax plus b, is only the first derivative of your denominator ax squared plus bx plus c. From the given form of partial fraction, it can be seen that the first and second term can readily be integrated using logarithmic formula and inverse trigonometric formula, respectively. In the succeeding fraction, n is greater than 1, with the numerator containing the factor of 2ax plus b, our first derivative of our denominator. Power factor will be used. Power formula will be used, while those fractions containing constant only in the numerator may be integrand using trigonometric substitution with the aid of suggestion of transformation by trigonometric formula, of course. Okay, so for our first example for case number 4, let's proceed. Okay, for your first example for case number 4, example number 35 can be found in your workbook on page 116. So example 35, evaluate the integral of x cubed minus x squared plus 1 all over the quantity x squared minus 2x plus 5. Okay, so case number 4. So it means that we have a repeating quadratic factor at the denominator. So our solution, so we need to resolve the integrand into sum of partial fraction. We rewrite our integrand into sum of partial fraction. Okay, so let's start with the numerator. X cubed minus x squared plus 1 all over the quantity x squared minus 2x plus 5 squared. Okay, remember that if your denominator has a power of 2, it means that your partial fraction, you have two partial fraction. Okay, so let's write our partial fraction. A x plus b all over x squared minus 2x plus 5. Remember, x is the first derivative of your denominator, and x squared minus 2x plus 5 is only your the repeating quadratic factor, plus your c x plus d all over x squared 2x plus 5 squared. So this is distinct quadratic factor, or we can rewrite this partial fraction into Rx is our first derivative of your denominator. That would be 2x minus 2 plus b all over x squared minus 2x plus 5 plus our second term c. Our x is the first derivative, 2x minus 2 plus d all over your distinct quadratic factor, which is x squared minus 2x plus 5 squared. Now, we need to write our equation. We multiply both equation by x squared minus 2x plus 5 over 1. The same. Okay? So, if we cancel common factor, so at the other side, we cancel this out. The remaining in our first term, We cancel 1. We still have a remaining since this is squared. Okay. We cancel one of our denominator. So the remaining, we need to rewrite. So after multiplying the equation with a factor x squared minus 2x plus 5 squared. So the remaining equation x cubed minus 2x plus 1 is equal to a 2x minus 2 plus b, and the remaining x squared minus 2x plus 5 plus your distinct quadratic factor, makakancel out lang siya. So the remaining is c 2x minus 2 plus d. So this is our equation 1. Not yet. We need to furtherly simplify our equation. We need to distribute this neighboring polynomial, the quadratic, inside the quantity. So we need to expand this partial fraction. If we do so, this is 2ax minus 2a plus b times its quadratic neighbor 2x plus 5 plus 2cx minus 2c plus d. We can still expand this one. So finally, x cubed minus 2x plus 1 is equal to 2x to a x cubed minus 6a x squared plus 14ax, that should be 14ax minus 10a plus bx squared minus 2bx plus 5b, and the second term plus 2cx minus 2c plus d. Now we have our equation 1. In our equation 1, we need to determine the value of a, b, c, and d. So we solve for unknown by equating the coefficient of x and the constant. So we start with the power x cubed. If we equate the coefficient of x cubed, okay, so we copy all the terms coefficient with x cubed. So we rewrite. Okay, so that is x cubed equal, here we have, so let's highlight coefficient with x cubed. So at the other side, 1, 2, we only have 2 with power of cube. Okay, so you only have 2. So you have x cubed is equal to 2ax cubed. So rewrite this one. You have 1 minus equal to 2a. So finally, we can say that the result of equating the coefficient of x cubed, a is equal to 1/2. We transfer 2 to the other side. So that is 1/2. So next is we equate the coefficient x squared. So if we start with x squared, we have 1, 2. So we have only 2 coefficient for x squared. Okay, so we rewrite. Correction. X cubed minus, this should be 2x. should be from our numerator x squared. So correction, we have 3 factor for your coefficient of x squared. So rewriting for your x squared, so you have negative x squared is equal to, you have negative 6a x squared plus bx squared. So remove all the square. So you have negative 1, negative 6a plus b. But we have a value for our a. We already determined a, which is 1/2. So that is negative 3. 6 times 1/2, that would be negative 3 plus b. So finally, if this is negative 1 plus positive 3, finally our b is equal to 2. Negative 3 will become positive. So positive 3 plus negative 1, that is 2. So you have the value for your b. Our next step, let's determine the value of our x, the coefficient of x only. So if we solve the coefficient of x only, what do we have here? X only. So at the other side, none. So we have 14ax, 2bx, negative 2bx here. So we only have 2. 14, 2bx, and also we still have 2cx. Okay, so we rewrite our coefficient of x only. So we have 0 at the other side. We have 14ax minus 2bx, and our last is 2cx. Recall that we have a value of a and b, so we can substitute directly. So 0 is equal to 14, 1/2, that is 7, 2, a value of our b is still 2, then our 2c. So here, we have 7, negative 4, 2 plus 2c, that is negative 3, that is 3. Then transpose it to other side, it becomes negative 3. Then all over 2. Finally, our c is equal to negative 3/2. Okay, so we have value for our a, b, and c. Now we determine the value of our d. Our d is a constant. Okay, so we need to equate in terms of constant also. So for our constant, we have positive 1, negative 10a, positive 5b, negative 2c, and d. Okay, so in terms of constant, equate in terms of constant. So you have positive 1 is equal to negative 10a plus 5b minus 2c plus d. Substitute the value of your a, b, and c to our equation. We 1, negative 10 times 1/2, 5, your b is 2, your c is negative 3/2 plus d. So the remaining term is only d, our constant d. So we can determine. So solving this equation simultaneously, finally, our d is negative 7. Okay, so we have a value for our a, we have value for our b, we have value for our c, and we have value for our d. Now we can write our partial fraction. Okay, moving on to our next page, we rewrite our function. we rewrite our partial fraction. Okay, so that is integral of x cubed minus x squared plus 1 all over your distinct quadratic factor x squared minus 2x plus 5 squared equal to integral, of course, the value of your a and b. You substitute a, x is the first derivative of your denominator, minus 2 plus b, x squared minus 2x plus 5 plus rc, the first derivative of your denominator, that is 2 plus d all over your distinct quadratic factor, 2x plus 5 squared dx. Okay, we can apply our property number 1 and 2. We let the integrand and dx inside the quantity of our term 1 and term 2 and carry out real number constant. But before that, you need to substitute the value of a, b, c, and d to your function. 1/2 2x minus 2 plus b all over x squared minus 2x plus 5 plus rc is negative 3/2 2x minus 2 plus rd is negative 7. Distinct quadratic factor x squared minus 2x plus 5 squared dx. Okay, so we apply property 1 and 2. Carry out real number constant and distribute integrand and dx inside to your function. And also, we can distribute this denominator to our numerator. So we can have 1, 2, 3, 4 terms. And we can integrate them separately. So we'll start with this. 1/2, it's a real number constant. You carry it out. Integral of the remaining 2x minus 2 quantity dx all over your repeated quadratic factor x squared minus 2x plus 5 plus your 2. You carry out 2 also. 2, since it's a real number constant. The remaining is dx all over x squared minus 2x plus 5. You distribute the denominator to its numerator. Next, so negative 3/2 times positive, that is negative 3/2. You carry it out already since it's a constant. So the remaining is 2x minus 2 dx over your distinct quadratic factor squared. You still have 7. So 7, negative 7, so it becomes negative integral of 7 dx all over x squared minus 2x plus 5 squared. So you have 4 terms. So you need to integrate each term. So start with first term. In first term, do we have to integrate 2x minus 2? No, you cannot integrate 2x minus 2. Why? It's the first derivative of your denominator. Once you integrate it, it will go back to its original form and cancel out your denominator also. So don't include 2x minus 2 in your integration. We only integrate 1/2 dx over x squared minus 2x plus 5. Okay, so in this first term, we can use our formula, logarithmic formula number 3, which is equal to du over u equal to ln u plus c. Okay, so we rewrite our first term right away. So that is 1/2 ln of your denominator, x squared minus 2x plus 5. Okay, so we're done with our first term. Moving on to our second term. In our second term, we have a denominator x squared 2x plus 5. We need to factor out this denominator. If we factor out x squared minus 2x plus 5, we can write it to x squared minus 2x plus 1 plus 4. So we can factor out x squared minus 2x plus 1. If we factor out x squared minus 2x plus 1, it will become x minus 1 squared, and 4 become 2 squared. So we can use ITF in this form. This is our A and this is our U. If we're going to use our inverse trigonometric formula, number 17, that is integral of du over a squared plus u squared is equal to 1 over a arctan of your u over a. So we can rewrite. So we have a constant at the outside, quantity. So our a is 2 squared. So it becomes 1 over 2. Then arctan. Our u is x from the factor x squared minus 2x plus 1. It will become x minus 1 over your a, which is r2, then plus c. Okay, so later we'll put the arbitrary constant of everything from term A to term C at term D. So we are done with our first term. We are done with our second term. So let's move to third term. At our third term, notice that we have a power. So logarithmic formula and inverse trigonometric formula is not applicable anymore. So we use power formula in this third term. Okay, so let's solve your third term. So that is negative 3 halves quantity. Again, you will not integrate since x or 2x minus 2 is only the first derivative of your denominator. If you do so, it will cancel out your equation, your function. Okay, so let's apply the power formula. Since x squared minus 2x plus 5 is at denominator, we can move it to the numerator and making our power to negative. So, okay, since it will become negative, so we can apply our power formula. That is x squared minus 2x plus 5. Since come from denominator, it will become negative 2 since galing siya sa denominator. So all over, negative 2 plus 1. So, okay, apply, it will become, the remaining is only negative 1 here, negative 1. So negative times negative, it will become positive. Okay, so it will be positive. So 3 halves times 1 still the same. That is 3 halves. Copy your numerator. That is x squared minus 2x plus 5. The remaining power, that is negative 1. So we are done with our term 1. Our second term, we also done. And our third term, we're also done. In our fourth term, negative integral 7 dx x squared minus 2x plus 5 is a different story. We apply trigonometric substitution. Since it's a quadratic, so we need to apply trigonometric substitution. Okay, but before you can apply, we need to factor out first our distinct quadratic factor. X squared minus 2x plus 5. The same here. We use the same factor. X minus 1 and 2 squared. Okay, so we rewrite. That is negative 7 dx. If we factor this out, we have, of course, we'll write the a or the constant first. That is your 2 squared plus x minus 1 squared. So we can use trigonometric substitution here. So we apply our trigonometric substitution. Recall that our a squared plus u squared can be written as u equal to a tangent theta. Okay, so we replace our denominator with our trigonometric substitution. So negative 7 dx, we replace with a trigonometric substitution. So we 2 squared, so it becomes 4. Then x minus 1 squared, we replace it with our a tangent theta. What is our a? That is 2 squared tangent theta squared. Okay. Of course, dx. We still have dx. It means that we need to apply our property number 3. We need to determine the derivative of your tangent. So we need to assume if x is equal to tangent theta, and if we're going to get the dx, that is 2 secant squared theta d theta. So we replace our dx with 2 secant squared theta d theta. So our function is in line. All of the term are in theta. So we replace dx with our theta. So 7 integral dx, that is 2 secant squared theta d theta all over 4 plus 4 tangent squared theta. Okay. So we have our fourth term. Is this ready for integration? Not yet. We still need to use some trigonometric identities. Okay. Moving on to your next slide. Okay. So we're done with our first term, second term, and our third term. So we're working with our fourth term. So here, after our trigonometric substitution, we have negative 7 integral of 2 secant squared theta d theta 4 plus 4 tangent squared theta. We forget the power. Since this is a distinct quadratic factor, we still have square here. So that is squared. So squared. Okay. So that is both squared. Our next step is to factor out 4. So negative 7 integral of 2 secant squared theta d theta. So if we factor out 4, that is 1 plus tangent squared theta squared. Remember that we have also a trigonometric substitution for 1 plus tangent squared theta, which is equal to secant squared theta tangent squared theta plus 1. That is also the same with this, 1 plus tangent theta. Okay, so we rewrite. Okay, moving to your next page. But first, we'll rewrite our first term. So for our first term, 1 minus 1 over 2 lone quantity x squared minus 2x plus 5, that is our answer for our first term. For second term, plus 1 half arctan our u x minus 1 over a, which is our 2. So that is for our second term. For our third term, we use the power formula, that is 3 halves quantity x squared minus 2x plus 5 raised to negative 1, since negative 2 plus 1 is negative 1. Okay, we are here for our fourth term. So a while ago, this is our first term. So we replace our denominator with a new trigonometric substitution. Secant squared theta is also equal to tangent squared theta plus 1. Okay, so we rewrite first this function. That is, okay, this is negative 7 integral of quantity 2 secant squared theta d theta. So we factor out 4, and for your 1 tangent squared theta squared, we replace this with our trigonometric substitution. Secant squared theta tangent squared theta plus 1 is also the same with this, so we substitute this value here. So 7 integral of 2 secant squared theta d theta all over quantity 4 secant squared theta squared. Okay, so next step, we distribute the power inside the function or inside the quantity. But before that, we need to reduce our common term. We have a common of 2. So we have also a common of 2 at the denominator. So the remaining is can we reduce? Okay, let's check our solution first. Moving back, 2 secant squared okay, we have 2, 4. Maybe we cannot cancel this out. Maybe we can remove just apply our power squared to the quantity. Integral of 2 secant squared theta d theta all over square of your 4, that is 16, secant squared, that is secant to the 4th theta. Okay, here we have a common, so we can cancel this out. Secant squared and secant to the 4th less 2 power, so the remaining is secant squared. Okay, so we rewrite 2, 7, we carry out this constant, that is 2 over 16. The remaining is theta secant squared theta. So can we integrate this now? We need to replace. Also, we need to use some identity. We all know that 1 over secant theta is equal to your cosine theta. Okay, so we replace secant squared. So 7 times 2, that is 14 or 16. That's 7 over 8. Negative 7 over 8. Integral of, we replace d theta over secant squared with cosine. Cosine theta. And of course, the power of your secant is squared. So cosine squared theta d theta. So now, we can integrate this one. Or introduce a new trigonometric substitution. So we move here. So we will move here. So that is negative 7 over 8 integral cosine squared theta. We have an identity for that. So cosine squared theta is also equal to 1 half 1 plus cosine 2 theta. Okay, so we replace our cosine squared theta with our trigonometric identity. So that is 1 half 1 plus cosine 2 theta d theta. Okay. Okay, what's next? So we carry out real number constant again. So we have 1 half. So that is negative 7 times 2, that is 16. Integral of 1 plus cosine 2 theta d theta. Okay, so we apply property number 1 and 2. So we distribute the integrand including the real number constant, negative 17 over 16. So if we distribute, it will become negative 77 over 16 integral of d theta, negative times positive, it will negative, that is 7 over 16 integral of cosine 2 theta d theta. Okay, so the integral of d theta, it will become negative 7 over 16 theta. Well, in our second term, that is negative 7 over 16. The integral of cosine 2 theta, that is 1 half sine 2 theta plus c. But we need to furtherly simplify 1 half sine 2 theta. You just carry out this 1 half, and use another identity for your sine 2 theta. So this is your identity 1, identity 2. We can still use identity. What is that identity? Sine 2 theta is also equal to 2 sine theta cosine theta. So we use this identity. Okay, here, you substitute it here. So negative 7 over 16 theta minus 7 over 16 times 1 half. It will become 7 over 32. Quantity sine 2 theta, we replace it with our identity. 2 sine theta cosine theta. So finally, our answer for our fourth term is negative 7 over 16 theta minus, okay, we cancel this out. 32 over 2, that would be 16. So 7/16 sine theta cosine theta plus c. So that is your answer for your fourth term. So we are complete. We're done with our first term, our second term, and our third term. But we have an unknown value for our theta. So we're not yet done. So we still have this theta, this sine theta and cosine theta. We need values for this. Okay, so let's recall. If we recall our integration in our fourth term, we have x minus 1 is equal to 2 tangent theta. If you remember, we replace x minus 1 with our, since this is square, our trigonometric substitution. You still can remember in our second slide. Okay, so if x minus 1 is equal to 2 tangent theta, therefore, your tangent theta or your theta is equal to x, that is tangent negative 1 or arctan x minus 1 over 2. So that's the value of your theta. But we still need to find sine theta and cosine theta. To do that, you need to draw a right triangle. Derive the values of your sine and cosine theta using your right triangle and your Pythagorean theorem. Since we have a value of our theta from our tangent, we can derive the formula for our sine and cosine. Okay, so for tangent, yes, we recall the trigonometric formula. So, towa. So this is your hypotenuse, this is your opposite, and this is your adjacent. For towa, that is your tangent theta, opposite you have x minus 1, and adjacent is 2. So you already have value of your opposite and adjacent. Substitute it to the value to your right triangle. So you have opposite. So that is x minus 1 and your adjacent 2. Therefore, you can determine your hypotenuse using Pythagorean theorem. Okay, so that is 2 squared plus your quantity x minus 1 squared, of course, the square root. So that is the value of your hypotenuse from your Pythagorean theorem. And if you combine this 2 squared plus x minus 1 squared, this is the factor of our denominator, which is x squared minus 2x plus 1. So we can write our value of our hypotenuse to square root x squared minus 2x plus 5. Okay, so we have hypotenuse. So we can derive our sine and cosine. So for our sine, that is so sine theta is equal so opposite. What is our opposite? X minus 1. Our hypotenuse is square root of x squared minus 2x plus 5. How about for your cosine? That is ka. Cosine theta, ka, adjacent, that is 2 over hypotenuse. Again, is square root of x squared minus 2x plus 5. Okay, so we have value for your sine theta, we have value for your cosine theta, and we have value for theta from our tangent. That is, theta is arctan or tangent raised to negative 1, quantity x minus 1 all over 2. So we have value for theta, sine, and cosine. So we substitute it back to our final answer. So we can rewrite our final version of our answer. Okay, so first term, that is 1/2 lone quantity x squared minus 2x plus 5 plus we have 2 1/2 arctan x minus 1 over 2. That is your second term. For your third term, we use power formula here. That is 3/2 quantity x squared minus 2x plus 5 raised to negative 1. And your answer here, that is, so we write first 7 over 16 theta sine theta cosine theta plus c. So we replace tangent with our theta, our sine theta, and cosine theta. So we can have our final answer. We can simplify further. Or here, we have a common of 2. We can eliminate 2. So your final answer, 1/2 lone quantity x squared minus 2x plus 5 plus arctan x minus 1 over 2 plus 3/2 x squared minus 2x plus 5. Okay, for your theta, we substitute the value. That is 7 over 16 minus arc tan x minus 1 over 2 minus your sine theta. Your sine theta is x minus 1 square root of x squared minus 2x plus 5 from here. And your sine theta, your cosine, 2 all over square root of x squared minus 2x plus 5. So plus your c, your arbitrary constant. Can we furtherly simplify this? Yes, combine this term. So we can furtherly simplify. Here, we can simplify. We can carry out 3 at the numerator and bring down this power since this is negative 1. Okay. So final answer, 1/2 lone quantity x squared minus 2x plus 5 plus arctan x minus 1 over 2. Here, we carry out, this since this is negative 1, so we put it at the denominator. So it will become 3 over 2 x squared minus 2x plus 5 minus here 7 over 16 arctan x minus 1 over 2 plus 2x minus 2 x squared minus 2x plus 5 plus c. So that is your final answer for your first example for case number 4. But still, you can furtherly simplify our final answer. Okay? But for the meantime, this is our final answer for our first problem for case number 4. Okay, moving on to your next example, your second example, case number 4. Okay, for your second example for case number 4, example number 36 can be found in your workbook on page 119. Example 36, evaluate the integral of x minus 2 all over x squared quantity 1 plus x squared squared dx. So if we observe, we have a power of 2, 3, a total of 6 partial fraction. Okay, so we rewrite our given function to partial fraction. Okay, so x minus 2 all over x squared, quantity 1 plus x squared, squared. So a, remember x squared, we have a repeating linear factor. So we're first with x, then plus b, the distinct linear factor, x squared. Then our c, this is supposed to be cx plus d. Again, we have a repeating quadratic factor. So we have quantity 1 plus x squared. Okay, plus d, our e, x plus f all over 1 plus x squared squared. So this is our distinct quadratic factor. So all in all, we have a 6 partial fraction, a, b, c, d, e, and f. Okay. Next step, cx. X is only the first derivative of your denominator, your quadratic factor. Okay, so a over x plus b x squared plus c, that is the first derivative of 1 plus x squared, that is 2x plus d all over 1 plus x squared plus e, again your x is the first derivative, that is 2x plus f all over your distinct quadratic factor 1 plus x squared squared. Okay, now we need to rewrite our equation. We need to multiply this partial fraction with our inverse, the inverse of our denominator. X minus 2, x squared, 1 plus x squared squared. So we multiply it with the inverse of our denominator, that is x squared, 1, then, or we can simply write it this way, 1 plus x squared squared. Okay, so we can write our equation. So x, cancel x squared, cancel. Then our x squared, cancel. Here, cancel 1. Still have 1. Here, cancel also. Okay, so we rewrite. So x2, that is ex. We only copy the distinct, okay? Distinct quadratic factor. 1 plus x squared squared. How about for your b? You still have the distinct b, 1 plus x squared squared. Plus about your c? Of course, the distinct x squared and the remaining distinct quadratic factor. C, 2x plus d times the x squared. You will not copy the repeating linear factor. You will copy only the distinct x squared and this one, 1 plus x squared squared. So they are your third term. How about for your fourth term? You only copy the distinct linear factor, that is a 2x plus f times x squared. Okay, so we multiply. You have ax multiply x times 1 plus x squared squared. So that is x to the fourth plus 2x squared plus 1 plus b, expand, that is x to the fourth plus 2x squared plus 1 plus c 2x plus d, multiply this one, this is x squared plus x4 plus 2ax cubed plus fx squared. So furtherly simplify, x2, this is x5 plus 2ax cubed plus ax plus bx4 plus 2bx squared plus b plus 2cx cubed, multiply with this, then plus 2cx 4 to the 5 plus your d, that is dx squared plus dx4 plus your e 2ax cubed plus fx squared. Your e x cubed. Okay, so we already have an equation. We can say that this is our equation 1. So from our equation, let's assume values to determine unknown. So if we say x is 0, if we let, or when x is equal to 0, okay, let's evaluate. If x is 0, the remaining is negative 2. So times x is 0, 0, 0, 0, 0, b. Negative 2 is equal to b, 0, 0, 0, 0, 0, 0. So it's obvious that our b is negative 2. If we move to another, if we equate, let's equate our coefficient x. Okay, so let's combine all factor with x only. X, so raised to x, so we have 1, x, x2, x1. Okay, we only have that one. We have x is equal to ax. Therefore, if we rewrite that, this 1 is equal to 1a. Therefore, our a is equal to 1. Okay, moving on to our next coefficient. Let's equate x coefficient x raised to 5. So if we equate coefficient raised to 5, so raised to 5. So here at this side, none. So here we have 1, 5, 5, 5, 5, 2. 5, 5, no, none. So we only have 2. So equate equation to 5, you have at the constant side 0. So you have a x raised to 5 plus ax. Okay, so no, is this 5? It's 2cx. That's 2cx5. So if we rewrite, that is 0, a, that is 1a plus 2c. But we have a value for a, that is 1. So 1, negative 1 is equal to 2c. Therefore, your c is equal to negative 1 half. Okay, we have a value for a, b, c. So since we have 6, we still have more to determine. Okay, we can use the space here. So let's equate x raised to 4. Okay, so raised to 4. Raised to 4. None. So we have 1. X raised to 4, we have 2. bx4 and dx. Okay, so 0 sa other side. So we have bx raised to 4 plus dx raised to 4. We have a value for our b. We substitute. So 0. What's the value for our b? Negative 2. Then plus d. Therefore, our d is equal to 2. Okay, so let's move to another. Let's equate x raised to 3 at x raised to 3. Okay, so we'll find x cubed. Oh, we have 1 squared 2 3 cubed. Okay, so but 0 in the other side. So for x cubed, we have 0 to a x cubed plus 2cx cubed plus 2a x cubed. We have a value for our a, we have a value for our c. So the remaining is a. So that is 2 times our a, 1 plus 2. What's the value for our c? Negative 1 half plus 2a. So solving simultaneously, your e is equal to negative 1 half. So this is 2, carry out 2, cancel over 2. Be negative 1, 2, so negative 1, carry out over 2, that's negative 1 half. This is correct. So E is negative 1 half. So A, B, C, D, and E. We still have F. So do we have still space? Okay, we can use this space. Let's maximize this before we go to our next page. We start E at E. X is 2 squared. So for x squared, we have 1. This for x squared. 2 and 3. Finally, we have f. We can solve f maybe this time. Okay, so on the other side, you have 0. Then this one, 2bx. Then dx squared. And plus fx squared. So substitute the value. So you already have a value for your b. b is negative 2 plus your d. What is our d? 2 plus f. Okay, so here, so negative 2 is negative 4 plus 2, that is 2. Negative 2, carry over. Other side, finally, your f is 2. Okay, so we rewrite our function since we already determined our a, b, c, d, e, and f numerator for our partial fraction. Okay, so we rewrite. Let's move to our next page. Integral x minus 2 x squared 1 plus x squared squared equal to integral. So we substitute the value right away. So for your a, that is 1 over x, plus your b, that is negative 2 over x squared. For your c, negative 1 half times your 2x plus your d, which is 2. All over the repeating quadratic factor, 1 plus x squared, plus your e, negative 1 half, times the 2x from the derivative of your distinct quadratic factor, plus your f is 2. All over the distinct quadratic factor, 1 plus x squared squared dx. Okay, so we have this, how many term? 1, 2, 3, 4, 5, 6 term. Okay, so if we have 6 term, we can apply our property number 1 and 2. We distribute integrand and the dx, so property number 1. Then we carry out real number constant. So when it's ready, we can use our integral formulas. Okay, writing it down. So here we carry out real number constant. 1 still 1. This is dx over x. Plus here, so this is negative 2. So 2 times positive, it will become negative 2. Then dx over x squared. So for our third factor, we distribute the denominator. Okay? We distribute the denominator here. So here, for our first, we carry out real number constant 1 half. Then the remaining is 2x dx over your repeated linear factor, 1 plus x squared. Oops, we still have 2. So plus, we carry out 2. Then dx over your repeated linear quadratic factor, 1 plus x squared. Okay, here, we break it into 2 also. So we carry out real number constant, negative times positive, negative 1 half integral of 2x dx all over 1 plus x squared. Squared, since this is a distinct quadratic factor, so we still have 2. So plus, we carry out 2 integral of dx over our distinct quadratic factor, 1 plus x squared squared. So we have 6 terms to solve. So for our first term, no power, we can use our logarithmic formula number 3 right away here. So that is ln x, ln x. Next is 2. We have a power, so we can use our power formula. That is x. Since it is at the denominator, we carry out to the numerator, it becomes negative 2 plus 1 all over 2 plus 1, negative 2 plus 1. Okay, solving for this is ln x minus, so this is negative 1, positive times negative times negative, that is positive. So that is 2x negative 1 minus here. Again, we don't include the x since this is only the first derivative of your factor. So we don't include that when we are integrating, okay? So here, we can use our trigonometric formula right away. So minus 1/2 ln 1 plus x squared. So we're done with our first, second, third. So here, maybe we can rewrite this one. So since it become positive, so this is 2 multiply. So we can rewrite it to 2 over x minus, in our second phase, we use our logarithmic formula right away here. So that is 1/2 ln 1x squared. Okay, so we're done with our 3 term. We still have 3 term to go. So okay, here in our fourth term, we can use our inverse trigonometric function here. We have x squared, we have a squared. So 1 squared is still 1. So we can use that relation. So that is 2 quantity. So 1 over a. Our a is 1. Then arctan. Then u. Our u is x. Then our a is 1. Is 1. Okay. So if we rewrite this one plus, so it will become 2 arctan x. They're only the same, they're only over with 1. Okay, so let's proceed to our fifth term. So negative, oops, we have a power. It means we use power formula here. Minus 1/2. Minus 1/2. So here we carry out to the numerator, it will become 1 plus x. Negative 2 plus 1 all over negative 2 plus 1. So negative times negative will become positive. So still 1/2. And negative 1, so we carry. So 1 plus x, you still have negative 1 here. We can still rewrite this. Okay, so we'll see. We still have one term 2. So ln x plus 3 over x minus 1/2 ln of 1 1 plus x squared, that is plus 2 arctan x plus, substitute it and bring it to the denominator, it will become 1 over 2 1 plus x. Okay, so we're done with our fifth term. So we proceed with our sixth term. So sixth term, it's different because we need to apply some trigonometric formulas here to solve this one. Okay, let's start. 2 integral of dx over 1 plus x squared squared. We carry out already. Okay, so if we factor out this one, a while ago, in our fourth term, we use arctan since we use our 1 squared. So here, the same. We replace it with our identity, with our inverse trigonometric formula. Okay, we replace. That is 2 integral dx. This is 1 squared plus x squared squared. Okay. Therefore, if we replace this one, we can use our identity. And carry out 1. Can you comprehend now? If we replace 1 squared plus x squared or carry out the constant one, you'll have 2 dx quantity 1 tangent squared theta. So this is from our trigonometric substitution, okay? So here we use trigonometric substitution to get 1 plus tangent squared theta. Now for our dx, usual, we need to get the derivative dx. So our x is tangent theta. Therefore our dx is secant squared theta d theta. Okay, so we replace our dx. So moving in here, we replace our dx with our secant squared theta. Okay, we write it here. So that is 2. So dx, we replace it with secant squared theta d theta. But for numerator, we already have 1 plus tangent 1 plus tangent squared. But before you can rewrite this one, remember that secant squared theta is equal to tangent squared theta plus 1. So it is the same at this and with this. So we replace quantity secant squared theta. You still have a square here. So square. Okay. So if we cancel square, square, the remaining is 2 integral of d theta. You still have secant squared theta. Okay, so this is the same with our first example. We still need to use 1 secant. So 1 secant theta, 1 over secant theta is equal also to cosine theta. So rewrite this one. So 2 integral of cosine theta d theta. But you have a power of 2. So copy power of 2. Here, we need to integrate or use identities. So here, what identities we're going to use? For cosine to cosine squared theta. For cosine squared theta, it has an equivalent of, for your identities, 1/2 1 plus cosine 2 theta. Okay, so replace cosine theta with our identity. 2 integral of 1/2 1/2 1 plus cosine 2 theta. Okay, so d theta. Okay, so we multiply 1/2. Multiply 1/2 with 2, so cancelled out. So the remaining is integral 1 cosine. We need to distribute, apply property 1 and 2. So if we apply property 1 and 2, here, we apply the integrand inside the quantity and d theta. So we have integral of d theta plus integral of cosine 2 theta d theta. So we integrate them separately. So now, okay, so integral of d theta, you can have theta plus your cosine. If you integrate cosine, you can have cosine equivalent to 1/2. That is 1/2 sine 2 theta plus c. Wait, we still have identities for sine 2 theta. Sine 2 theta can be written also as 2 sine theta cosine theta. So we replace sine 2 theta with this. So finally, for your sixth term, theta plus 1/2 times 2 sine theta cosine theta. So okay, so we cancel out 2. So the remaining is sine theta and cosine theta. Theta plus sine theta cosine theta plus c is the remaining. So we cancel out 2. Okay, so finally, we can rewrite our answer. Starting from our term 1. We'll start from our term 1. So that is ln x plus 2 over x minus 1/2 ln 1 plus x squared plus 2 arctan x plus 1 over 2 1 plus x squared. So lastly, our theta plus sine theta cosine theta plus c. Okay, so this is our answer, but we still need to find the value for our theta, sine theta, and cosine theta to say for our final answer. Okay, if we recall the value in our derivation in our equation 2, we assume x tangent theta, so we can use this to determine the value. Okay, so from x is equal to tangent theta, we can say tangent theta. So 1, so that is your tangent theta is also equal to, so you have 1 x over 1. So if you're going to derive, therefore your theta is tangent negative 1 x over 1. So this is the value for your theta, or theta arctan x over 1. And if we draw a right triangle, we can determine the other one. So this is your opposite, hypotenuse, and the adjacent. So towa. So opposite, so tangent, we have a data. Tangent, opposite is x. A adjacent is 1. So we can determine our hypotenuse. Okay, so this is 1 squared plus x squared. So square root. So if you recall our factor, we can rewrite this to square root of 1 plus x squared. So we have value for our hypotenuse. So going back to our sine. So sine theta is equal to opposite. What is our opposite? X. And hypotenuse is square root of 1 plus x squared. How about for our cosine theta? For your cosine theta, adjacent, you have 1. Hypotenuse, 1 plus x squared. So we have value for your theta, sine theta, and cosine theta. So finally, we can write our final answer. So rewriting your final answer, we'll substitute right away the value of your theta from tangent, the value of sine theta and cosine theta from your right triangle representation using Pythagorean theorem. So final answer, ln x minus 2x, 2 over x minus 1/2 ln quantity 1 plus x squared plus 2 arctan x plus 1 over 2 quantity 1 plus x squared. Okay, plus we have a value for theta. Remember, we have tangent negative 1 x over 1. So we can write it to arc tan equal to x. Since x over 1 is still x. And the value for your plus your sine theta. Sine theta, that is x over 1 plus x squared. And for your cosine theta, that is 1 all over 1 plus x squared. Okay, but don't forget your arbitrary constant c. Okay, so that is your final answer for your second example for case number 4. Or we can simply combine this. We can rewrite this to x 1 plus x squared. Rewrite it, copy the same. So, for question, you can comment down below, or you can send your question to our GC, or you can send me your personal message to your Moodle account. So, okay, so that would be all for our integration by partial fraction. I hope you get some technique and ideas in solving partial fraction decomposition. So, I think that would be all for today. Thank you everyone and have a nice day.